Section 20.3 is about solving simultaneous equations, linear ones, that is straight line graphs, and obviously two straight lines, provided they have different gradients, will cross over somewhere, and when they cross over they share a common x value and a y value. You can read off the x value if you read straight down to the x-axis, or read across to get the y value. In fact, you need both of them to get the x and the y solution for each graph, for each equation. Therefore, by virtue of plotting a couple of equations, two straight lines, point of intersection, solution is done. A bit long-winded, and so there's shortcuts to plotting these lines by not taking a whole series of values that you have to calculate for x and y for each line. Look at this, for example. This is 1e. This is on page 298. See if this pen will come up. There we go. I've got an equation. It says 7x plus 3y comes to 5, and I've got to solve it simultaneously with this one. 15x minus 3y equals 6. So I've separated them out, so I do my calculations there in the mid. So what I want to do therefore is, if I designate x as 0, so I put a 0 right there, 7 zeros is nothing, and I'm left with 3y equals 5, from which y becomes 5 over 3, or 1 and 2/3. It's going to be a pain to plot, but anyway, what I've done is created the coordinates 0, 1 and 2/3. Is that okay? So difficult to plot, but it can be done. And this time let's just rewrite the equation again. In fact, let's get this out of the way. I'll come back to that one later. Rewrite the same equation, so you've got lots of space to calculate one other coordinate. Remember, you need two coordinates to get a straight line. So this time I'm going to make the y 0. If I plant a 0 in there, 3 zeros are nothing. I'm left with 7x equals 5, from which x equals 5/7. So I've now got the coordinates x is 5/7 and the y is 0. So if I plot these two right now, I'll get a straight line, but it's not very easy to plot it on a grid like this when you've got fractions. Anyway, 0 across 1 and 2/3. So that's 1 and 2/3 is about 1.6 recurring. So there you go, it's about there. That's 0. That's that one done. Now we're going to do 5/7 and 0. And 5/7 and 0. So 5/7 is about 0. Let's just take a good look at that. Quite difficult to judge, really, isn't it? So what's 5/7? Try and do it now. So 5 divided 7 equals 0.71. Try and find a 0.7 just over here somewhere. That's 1, so that's 0.7 is going to be about here. Right, so that's 7/5 0. So if I get my straight line arrangement going now, and if I plot it across like that, oh, it's too thick. No, thin it out a little bit. I'll plot it like that, and I don't know what it's going to end up. Maybe I should extend it back here as well, see what happens. Yeah, it's not perfectly straight, but yeah, it's the best I can do. Right, so that's that one done, and I better just label it and get it out of the way. This one is y. No, sorry, it's 7x plus 3y equals 5. That's that one. That would be more like a 3. Now I've got to do the same with the other one. Now you've probably forgotten it, because I have as well. I've got to solve 7x plus 3y equals 5 alongside 15x. I mean, these are quite tricky to plot, aren't they? Equals 6. So let's make again same technique. If I make x equal to 0, so 15 nothings have gone. I've got minus 3y is 6, from which y equals 6 over minus 3, and that gives us minus 2. So I've created the point 0, minus 2. 0 minus 2 is right there, so plant it just there. Rewrite the equation again in blue so I can show you the full calculation. I did say blue, didn't I? So 15x minus 3y equals 6. This time we're going to make the y equal to 0, so that's gone. I've got 15x equals 6, from which x equals 6 over 15. Simplify it down. That's going to be 2/5, isn't it? Now 2/5 is 0.4, so you know that. So I've now got the coordinates x for takes value of 2/5, and of course the y value is 0, isn't it? So there it is. So 2/5 and 0. Well, 2/5 is 0.4, so 0.40 is going to be right there, I'm sure. So I've now got to whack it up there using a blue line. This facility right here. Let's see how we go. So again, this is pretty crude, isn't it? Best we can do at the moment. So as I say, I don't need to extend the line backwards, but I will, so it looks all nice and big and important. There, so I've got the 2 points of intersection, sorry, 1 point intersection. Let's just label this line, that's what I've just drawn in, and this one is 15x minus 3y comes to 6. Again, really tricky equations. Now, let's change colour to make it all big and important. Let's go for this green thing here. Now, x equals and y equals, let's get our answers. Well, if that is 1, 2, 3, 4, 5, then I think I've got it bang on 0.5. Again, in an exam, hopefully there'll be more space for you to show the examiner what's going on. So you should really sort of draw a little line like that and say, there's my answer, it's barely visible. Anyway, I'll make that 0.5 or a half. And this one's a lot easier to see. Look, turn left, draw it in, put the arrow, and look, 0, 0.51. Y is also 0.5 or a half. So that's the solution. I've now solved a pair of simultaneous equations by each plotting a graph for each equation, seeing the points of intersection. The x is a half and y is a half, and that's the solution for each equation. It works. So let me pause the video and then stick another one on the back of it and then join them all up. Moving on to 1F of question 1, page 298. I've got this awkward little thing to have to do. Look at this one here, it's horrid. I've got to do 5y plus 2x equals 15.5, 15.5. Again, no worries, we have a calculator. So if I just work down here, give me space to do the calculations for the other one, and it's 3x minus 5y equals 4.5. There's the decimal point there. So that one and that one, both got to be plotted. We're looking at the points of intersection, therefore where they share the common x and y value, that's the solution to solving those two equations. Alright, so usual technique as per earlier, make x 0, so cross it out because x is 0. So I've got 5y comes to 15.5, so y is going to be 15.5. Again, simple solution is going to be 3 and a bit, isn't it? 3.1 I think, let's just check it out. So 15.5 divided by 5, yeah, 3.1. It's going to be a pain to plot, but we'll have to have a go. So 3.1, so I've got the coordinate 0 for x and 3.1 up the y-axis. So that's that one done. May as well plot it. 0, 3.1, right. 1, 2, 3.1. So 3.1 is one little square above the 3. That's a little bit crude, but okay, let's just do it better then, shall we? A little bit better. Put the black in place. Right, 3. Black, 3. And 3, oh, let's do it again. Right, black. So there's 3, right. Now 3.1 is just one little notch above that, which is barely visible on the screen. Alright, I'm going to leave it there, no arguments, that's it. Let's just do another one quickly. And this time we're going to substitute y as 0 and 2x equals 15.5. Right, what we've got now, we're going to make y 0. So that's gone bye-bye because 5 nothing's a nothing. 2x equals 15 and a bit. So x is going to be, oh dear, it's going to come off the scale. That over 2, and that's going to be 7.5. Oh, 7 point. Let's just do it. 15.5 divided by 2. Yeah, 7.75. I'm going to have a lot of fun with that. 7.75. Right, so x is 7.75 and y is 0. So 7.75. So 6, 7, 8. So 7.75 is going to be right there. There you go. Absolutely fantastic. Why don't I extend the line for being a complete idiot? There we go. Extend it all the way down here. There you go. Beautiful. Let's just put some extra little numbers in. So 5, 6, 7, 8, and that's 7.75 sort of. And let's close off that coordinate there and plot it in red or blue usually, isn't it? Right, from there to there, whack it straight in. Put it there. Right, that's sort of okay. Okay, that's that one. Lovely. Well done, me. And the next one I'm going to do is do a calculation for the bottom one now. So we'll make x equal to 0. So that's 0. So minus 5y is 4.5. So y is going to be minus 4.5 over 5, or 4.5 over minus 5, makes a difference. Get the same answer. So that's going to be basically 9 out of 10, 0.9, isn't it? But it's negative. Minus 0.9. I can see that. So what have I got then? I've got the coordinate 0 minus 0.9, so that's that one. So 0 minus 0.9 will be right here. It's near enough. Let's just do another one. Revert to blue and just work over here somewhere. So I've got again 3x minus 5y is 4.5. This time I'm going to make the y 0. So y 0, goodbye. And 3x equals 4.5. So x is going to be 4.5 divided by 3. And 3 is into 4.5, go 1.5 times, so it's 1.5. Coordinate 1.5 for x, 0 up for y. So 1.5 is 1.5, that's dead easy to plot, isn't it? Whoosh, up we go. There's our point of intersection coming through right now. Put it straight through there, and that's sort of what I make it. And no need to extend it right across my calculation. And this time I'm going to show you a nice pretty little thing to do for the examiner. You go like that, then you go like that, and you stick a pretty little arrow on it, and you go like that and like that, and then you write down ever so boldly in a pretty colour, like what haven't we done yet? Let's try a pretty that one. And then let's say x equals 0, 1, 2, 3, 4. So exactly x equals 4 and y equals 0, 1, 2. I'll make that 1.5. So I'm really happy with that. Yeah, after all that heartache and coming off the scale, and they never told me not to do that. I was told for each question, consider x values from 0 to 5. Well, can you imagine? I didn't want to do that. I just like to do it the proper GCSE way and make the x 0, then the y 0, and then get 2 coordinates and plot it. If you get stuck like that in the exam, then you have to use a different technique. Doesn't matter, you get there in the end. Right, that's it. So x equals 4, y equals 1.5, and that will do one video for question 1. I'll do a couple of questions in question 2, and one more question from either question 3 or question 4, which is a word equation that generates equations. Oh, it's a word problem that generates 2 simultaneous equations, which can be plotted and then solved. No problem. Alright, so see you soon.